so let's look at this. Y equal x minus 1. So we know that's a line. Y-intercept of negative 1, slope of 1. So something like that. And let's graph this x equal y squared minus 1. So it's facing to the positive and it's shifted down by 1. So down this way. And it moves like this. I'm not sure if it, yeah, I guess it does cross at the same point. Okay, so now we see the area bounded is right in here. All right, so now let's find which kind of rectangles we would choose to do. So if I draw rectangles with the top here and the bottom down here, then I can see I'm going to have blue on the top, red on the bottom for a while, but over here I would have blue on the top and blue on the bottom, so that is not a good choice. So let me get rid of those little notations there. All right, so let's go back to what kind of rectangles would I want to use. I'm pretty sure if I use rectangles that go sideways like this, where this is the top and this is the bottom, I always have the same function on the top and the same on the bottom. So let's do sideways rectangles to find the area. So it's going to be dy integration. So the top function will be the line, and so I know I need to put y's in here. So let's take this y equal x minus 1 and solve it for x equals. So that's y plus 1 is equal to x. So y plus 1 is the top, that's the line, and then the bottom will be the y squared minus 1. So be really careful. You have to put parentheses around that for this subtraction to carry through, and then you have to isolate, completely put in parentheses all that you're integrating with respect to y. So now I need to find out where they intersect. So I'm going to be setting x equal y plus 1 equal to y squared minus 1. So since it's a quadratic, let's get it equal to 0. So let's pull this over to the other side, minus 2. So that will give me y minus 2, y plus 1. So that gives me from negative 1 to 2. All right. So let's look at this. X equal 5 minus y squared. So it's up here at 5, upside down, facing this way. And then x equal 4 looks like this. So the area bounded is right in here. And so I want to use sideways rectangles again. So I want to use the top of the rectangle here and the bottom of the rectangle down here. So it is dy integration. So let's put that first. All right, so top of the rectangle touching the 5 minus y squared. Subtract off the bottom of the rectangle touching x equal 4. And then from where to where? So whoops, where am I building rectangles from and to? So I want to be setting the two equal to each other. So 4 equal 5 minus y squared. So y squared is 1, so y is plus or minus 1. So from negative 1 to 1. All right, last one here. So I've got x equal y squared minus 3. So it's shifted down by 3, facing upwards. And let's get this one, x equal 3 minus y squared. So here it's at 3 and it's facing downwards. Pretty sure they're going to cross the y-axis at the same place. So let's think about how we're going to want to draw the rectangles. We're going to draw the rectangles sideways, where this is the top and this is the bottom. So let's do dy integration. So I'm going to have the top function, which is the red, which is the, sorry for the noise, minus y squared. Subtract off the bottom function, which is y squared minus 3. All of that is in the integral with dy integration. All right, so let's find out where they intersect. So I'm going to have y squared minus 3 equal 3 minus y squared. So I get 2y squared is equal to 6. Y squared is 3, so y is plus or minus root 3. So negative root 3 to positive root 3. All right, so the rest of the page here, I've just given you a couple more u substitutions, making sure that you know the derivative of ln of 3 to the x, and playing with harder u substitutions. So make sure that you have these memorized because they are crucial. So this is new and this is new. And I'll be able to show you why in Math 151, but for now you just need to memorize it. So notice that arcsine does not have a 1 over a in the front. Arctangent does. Okay, so this is exactly, looking at the new arcsine formula you've got, this is inverse sine of x over 3. So just need to memorize it. So knowing that, let's think about what I've got here. This fits the pattern if I do a clever u substitution. So the clever u I'm going to use is let u equal sine of x. Then du gives me cosine of x dx. So let's rewrite that so you can see what I'm looking at. So I've got sine of x all squared times a cosine of x dx. All right, so cosine of x dx gets taken care of with a du, and then I got 1 over 16 minus u squared. So this gives me okay, there we go. So using this, I get the arcsine. So I'll get arcsine. So I get inverse sine of u over 4 plus c, because 16 squared gives me the a is 4. And so then putting the x's back in, I get sine of x over 4. That's the angle inside the arcsine plus c. All right. Looking at this next one, comparing with what I know now, I've got this new arctangent. So this gives me 1/2 arctangent of x over 2 plus c. Just need to get that memorized. All right, and I'm giving you one right away like it, where I want you to use the clever u substitution. So let me split this up so you can see what I'm thinking about here. So I see e to the 2x is e to the x squared, and then I have this e to the x off to the side. So if I let u equal e to the x, du is e to the x dx. So this can be replaced with du, and then I have 25 plus u squared, substituting the u in here. So I can see this fits my arctangent, so I get 1/5 arctangent of u over 5 plus c. And so now I could put the u back in, so that's e to the x over 5 plus c. All right.